So this is always a very fun part of our conferences. It's usually it's done in person, and usually I'm trying to speed eat some food so we can get going with it. Things are different today. We are going to be giving out our annual Wolfram Innovator Awards, recognizing people who've done really interesting things with our technology. I built our whole technology stack in part because I wanted to use it myself, and I have a lot of fun doing that. And I'm always a little bit envious of all the things that I see other people doing with our technology because there's so many really, really cool things. I had a chance to, a few of the people who are receiving awards tonight, I already knew. I had a chance to meet everybody earlier today, and that was a pleasure. So what I'm going to do is present these awards, and I'm going to say a little bit about each person. And so I will apologize in advance if I get a bunch of stuff wrong, and people can correct that later or on chat or something. But I wanted to try and tell you a little bit about what some of the projects that some folks that we're recognizing tonight here have done. And we're going to go through the, for people's logistical benefit, we're going to go through in alphabetical order of last names. So without further ado, let me go to our first, I hope I'm successfully sharing my screen here. Our first Innovator Award of the evening is going to Pedro Balbi of Mackenzie University in Brazil. I first met Pedro when he came to our 2003 NKS summer school that was started just after my big book, New Kind of Science, came out. And Pedro worked on cellular automata there. His background was that he'd originally got an electrical engineering degree in Brazil, then applied computing master's degree, then a PhD in cognitive science at the University of Sussex in England in 1995, and then had been a postdoc in Canada. He came to our summer school and worked on problems of kind of matching evolutionary computation with the kinds of things that we try to do with cellular automata. And he's been particularly interested since that time in making cellular automata compute interesting things. And in fact, he's had, I think, as many as 50 students altogether at Mackenzie University in Sao Paulo who've worked on things related to cellular automata with him. I think a problem of particular interest has been problem of having a cellular automaton which has lots of cells which are all operating separately in parallel, having the cellular automaton be able to sort of collectively answer a question. So an example is the parity question. Are there an even or odd number of black cells in the initial condition for the cellular automaton? And Paolo was just telling me today about new progress recently made in solving that problem on generalizations of cellular automata that involve not just synchronous but asynchronous updating on graphs and so on. So Paolo, who's I had the pleasure of visiting with Paolo at his university in Sao Paulo in summer of 2018, and got to see some of the labs that they have there. And through Paolo's work, every electrical engineering graduate student, for example, at the university is exposed to Wolfram language and also exposed to cellular automata. And that's a really nice thing to see. I think also Paolo has been involved in organizing the automata family of conferences, which I happened to attend recently virtually, as well as producing a Wolfram language cellular automaton toolbox, which is available freely. So our first award for the evening goes to Pedro Balbi. And I think the theory of this is that, here we go, I hand this way, and Pedro does that. Okay.
Thanks a lot, Stephen. Many thanks.
My pleasure.
I'm honored.
Thank you.
Thank you.
All right, let's see. So our next Innovator Award of the evening goes to Kenneth Bogan. Kenneth is in Maryland, and he is a toxicologist with a long and interesting history. first got exposed to our technology on Next computers. He was a scientist at Lawrence Livermore Lab. And back when Nexts were new, probably in 1989, Kenneth got started to use Mathematica on the Next computer. And he was involved in assessing risks associated with various kinds of public health things to do with tumor-inducing agents and other things. And at that time, he tells me he started building a package called RISC-Q, which is kind of a pun on the Wolfram language convention of using Q at the end of functions that ask a question. So RISC-Q is kind of asking, is there a risk associated with something? And Kenneth, to give his background, got a bachelor's degree in biology at Princeton, master's degree in science, technology, and public policy at George Washington University, and then a Master of Public Health and Doctor of Public Health and Environmental Health Science at UC Berkeley. And from there went to Lawrence Livermore Lab, where he worked for about 20 years. Following that, 10 years at consulting firm, consulting on health risk assessments in a variety of different settings. I think I was struck by seeing, let's see if I can pull up. Yes, it seems as if the activity of being Kenneth is a board certified toxicologist. It seems this is a very interesting mixture of kind of statistical analysis, of taking studies that have been done of particular kinds of risks together with actual physical modeling of things. So I noticed in Kenneth's body of work, actual modeling of the human nasal cavity to study the effects of to do with predicting zinc ion diffusion within the mucosa in the human nose. Kenneth was actually telling me today that in addition to his work in toxicology, he's been very interested in the sort of fundamental science of cancer, and actually has developed a kind of new hypothesis about the way that cancer is initiated that relates to the process of inflammation that happens. He has a hypothesis that inflammation is key to the initiation of cancer events in cells. And I think Kenneth is something of an expert on inflammation. And as some of you know, in the really bad cases of COVID, one of the things that can happen is a so-called cytokine storm that leads to a sort of runaway inflammational response. And Kenneth has been doing work recently in connection with that, in connection with the pandemic. I'm looking at lots of other interesting examples of Kenneth's work here, but I think we should just present Kenneth with 2020 Wolfram Innovator Award.
Well, thank you so much, Stephen. Thanks very much.
My pleasure. All right, let's see. Our next award is going to Thomas de Camino. So Thomas has a very eclectic background. He's based in Costa Rica. He's been involved in many different things. He kind of started life as a biologist, first studying in Costa Rica, then getting his PhD in mathematical biology at the University of Alberta. Somewhere in the middle of that, getting a master's degree in computer science, also in Costa Rica. As part of that master's degree, created a language for programming cellular automata with applications in biology. His PhD was on biological control and case study with scentless chamomile. Thomas tells us his first experience with Wolfram language was using Mathematica 4.0 back in the year 2000 for doing spatial analysis of satellite images, then for working on matrix population models and with differential equations describing population dynamics and so on. Needless to say, maybe I jump ahead in the story, anybody who studied population dynamics with differential equations is likely to have been called into action in this past year because the equations of epidemiology are the same kinds of equations. But in any case, Thomas used Mathematica and Wolfram language in teaching computer science, automata theory, also made use of our capability to connect to Arduino microcontrollers, and has been very involved in Costa Rica in the development of the maker movement there, in the ability to have students be able to actually build things with 3D printing and so on, and go from the digital to the physical. In addition to his other activities, Thomas has also been a music producer, produced more than 60 albums of Costa Rican and Central American musicians, and has created a digital record label with a new business model. And the name of the label is Automata Records. That's a really cool name. He's also produced some of his own music using electronic instruments that he's created using algorithmic methods. So in the current times of COVID, Thomas said he thinks he might be the only mathematical biologist in Costa Rica. So quickly got involved in being interviewed and being called in to help with government policy in Costa Rica, doing SIR modeling to predict epidemics, the growth of the epidemic, and so on. And he tells me that he's one of those people who has had a chance to actually use Wolfram language live in media interviews. That's something I always enjoy doing, to explore aspects of the pandemic and its consequences. So he's also been recently involved in the spreading of kind of computer technology and maker technology within Costa Rica, not only using microcontrollers, but also a pilot project using Raspberry Pis with Wolfram language as a computer to provide to students in a distance learning university, where in addition to giving students books to study with, he's had a chance to get them given Raspberry Pis so that they can do computation as well as read from books. So our next Innovator Award of the evening goes to Thomas DeCamino.
Thank you very much.
Pleasure. All right. Our next award for the evening goes to Branden Fitelson of Northeastern University. And I've known Branden for some years. He is a philosophy professor. He does a lot of interesting things in applying computation to philosophy. I think he was very early in the world of being a computational philosopher. He got his bachelor's degree in mathematics at University of Wisconsin and his PhD also at University of Wisconsin in philosophy. Even from the time when he started using Wolfram language and Mathematica for his thesis project back in 1994. And really, I think he tells me that a lot of what he's done has been enabled by a lot of work that we did in algebraic computation, particularly the creation of the reduce and resolve functionality in Wolfram language that allow one to take arbitrary systems of polynomial equations and inequalities and be able to algorithmically resolve them. We were very proud of that technology, and it's just wonderful to see that a computational philosopher is one of the beneficiaries of that activity. Branden has been particularly concerned with trying to sort of rewrite some of the foundations of the way that logic is thought about. Logic is an old business going back to Aristotle in the 4th century BC or so. But the sort of modern version of logic probably dates from the 1920s, when things like truth tables were invented by people like Post and Wittgenstein and so on. Branden tells me that he wants to see a kind of, after 100 years, it's time to revise the way that we think about and teach logic. And he thinks that the core of logic should not be so much the structure of truth tables, but more a kind of an approach that's more based on probability and more based on the kind of algebraic analysis of probabilistic expressions. And so he is planning to write a computational textbook along those lines. He created quite a while ago a package called PRSAT, which is a Wolfram language package, and he's been using that for research and education for many years now. I think for me, looking through Branden's list of publications, I saw one which was about computational metaphysics. And I've been saying for a while that for every X, there either will be or there either is or will be a computational X. And I think Branden back, maybe it was 2007, put his stake in the ground for being perhaps the first person to coin the term computational metaphysics in print. Our next Innovator Award goes to Branden Fitelson.
Thanks so much, Stephen. Really an honor. Thank you.
Okay, our next award goes to Virgilio Gomez. And so Virgilio and us is in a sense a COVID story. Virgilio did his bachelor's degree and master's degree at Texas Tech University, and then working on solid mechanics, and ended up using Wolfram language and Mathematica to develop a method for improving kind of the solving of partial differential equations in flexible structures and structures with cracks. He, being able to find semi-analytical solutions, as I understand it, for figuring out vibrations of materials like that, greatly improving on the kind of numerical methods that had previously been used. But then Virgilio, who's a mechanical engineer by training, started working at quality aspirators and using Wolfram language and Mathematica as his tool of choice for a whole variety of projects, from facial reconstruction for custom face shields to other things. And when COVID hit, one of the products for Virgilio's company is something for dentistry. As one may know, there are two meanings to the word calculus. One of them is the thing that Leibniz and Newton and so on invented. The other is the kind of stone-like stuff that builds up on one's teeth. The small stone was the original meaning of the word calculus, and the one from which the idea of counting and calculation came, and that led to the calculus of Leibniz and Newton and so on. But anyway, Virgilio was involved with the other kind of calculus, and in particular with ultrasonic scalars, the kind of thing that allow you to clean calculus off a tooth. And apparently one of the main issues, I guess I'm not surprised by this, one of the main issues with an ultrasonic scalar that's scraping stuff off a tooth is that it gets really, really hot. And the way you prevent it from the way that you cool it down is by spraying water. And when you spray water, you get a bunch of water droplets. And when the pandemic hit, having water droplets near mouths was really a bad thing. And so a solution had to be found to avoid this spray of water drops. Apparently, there's a notion of four-handed dentistry, which means both the dentist and the hygienist being there, and the hygienist potentially sucking all those water drops away. But there's a great desire to be able to do two-handed dentistry, particularly if you want fewer people in the office in the time of a pandemic. And for that, you need some more automated way to clear that whole spray out of the way. And what Virgilio did was to use, and this is a project of the moment, so to speak, was to use Wolfram language image processing, and there are some pictures actually illustrating it, use Wolfram language image processing to be able to figure out, was it possible to suction in this spray of aerosol droplets? And he did that by literally taking images like the one on the left there, and counting drops, thousands and thousands of drops, and figuring out, using Wolfram language, doing an analysis which has led to successful deployment of a product that lets dentists get back to work and do ultrasonic scaling and clean our teeth. So our next Innovator Award goes to Virgilio Gomez.
Thank you so much, Stephen. It's an honor.
Thanks. Well, our next Innovator Award of the evening goes to Greg Hurst of United Therapeutics Corporation. I actually know Greg quite well because Greg worked at Wolfram Research for a number of years, and let me tell you a little bit of that story. So Greg studied mathematics at University of Illinois and computer science, got his master's degree in mathematics at Purdue, and then in 2015 joined Wolfram Research and was involved in mathematics development for Wolfram Alpha and creating some of the very popular kinds of step-by-step computation that we provide to students in Wolfram Alpha. Greg also was working on 3D printing and on the computational geometry of 3D printing. In fact, for a while, Greg worked in the kernel development group on computational geometry before eventually getting pulled back into doing more educational mathematics development for Wolfram Alpha. And I should say that as part of Greg's work on kind of the educational side of technology, he's involved in our summer camp and was the academic director of our summer camp for a couple of years. And I had the pleasure of working with him on figuring out lots of interesting high school student summer project kinds of proposals and so on. But on the side, Greg was working on computational geometry, and in particular on the 3D printing of very filamentous structures. It's not an easy thing to, when you're going to 3D print something, there are a bunch of physical constraints associated with how you can actually build up that thing that you're printing. For example, it better be the case that you can't print something that's going to be sort of suspended in midair, at least not unless you build supports that you later have to remove. And when you're building a kind of a complicated filamentous structure, you have to make sure that it's possible to get each filament, each piece of the structure actually built without the print head running into things and without all kinds of other problems like that. Well, Greg did some nice work on that and published some papers about it, and was discovered by a company called United Therapeutics, which had the very ambitious project of print a human lung. United Therapeutics is the latest venture of Martine Rothblatt, who is famous for Sirius XM radio and for going from satellites to drug development and executing a series of very implausible kinds of projects, just my kinds of projects. But they're now working on the project of printing a human lung, and Greg was brought in as the computational geometry and mathematical talent to make it possible to print a human lung. What's involved in printing a human lung? Well, ultimately, there's a framework that's made of cartilage, and the concept is to print that framework made of cartilage and then progressively wash it with different kinds of cells to build up the actual biological structure, cellular structure for the lung. And our lungs are a very interesting mathematical structure. They're kind of a binary tree structure, and they're a binary tree that, we have two lungs and then it branches again and then it branches again. It actually branches 23 times until it gets down to the point where the sort of distance from an airway to the blood is just 200 nanometers. So the challenge of United Therapeutics and Greg's work is to get to the point where you can print the cartilage all the way down to that kind of scale. And I think I realized talking to Greg today that Greg is probably the world's only lung designer. He's the only person who gets to figure out what that structure for a mathematical point of view should be like, because to some extent one needs in building an artificial lung to imitate the biology so that it's possible to be used in us humans, but also one gets to improve on the biology and actually solve engineering problems in different ways. And as I say, I think Greg is the unique example in today's world of a lung designer, and we certainly wish him the best of luck in being able to get to the point of having an actual operable artificial lung. And I think we had a picture here. Yes, okay. I think that's a printed heart, not a printed lung. And I think the technology there is, I think that was during the time when Greg was thinking of printing things out of sugar. And that's different from the current plan, but that's an indication of the kind of thing that is being done. So I'm pleased to present our next Innovator Award to Greg Hurst.
Thanks, Stephen. It's a real honor.
Thank you. Our next Innovator Award of the evening goes to Ambar Jain of the Indian Institute of Science Education and Research in Bhopal, India. And Ambar, like so many fine people, started life as a physicist, first getting a bachelor's and master's degree from Indian Institute of Technology in Kanpur, and then getting a PhD at MIT, followed by postdoctoral research at Carnegie Mellon. His PhD project was about QCD, studying, he studied penguin diagrams. Cool, okay. In the heart of kind of phenomenological QCD. But now he's been using Wolfram language and Mathematica in lots of different projects, not only in physics, but also in the process of education. Recently started a new physics course with computational thinking using Wolfram language. But one of his big projects has been the creation of a system called Examiner, which is an assessment engine for assessing students at his institution. And one of the challenges is that there's a sort of continual arms race. I have this feeling that it's more challenging in India than in other places, because somehow the students are more creative there in the arms race between being able to do sort of correct assessments and having students cheat in one way or another. What Ambar has done is to build a system based on Wolfram language, using our cloud technology to create an assessment system where different students are able to be randomly fed in real time different variants of exercises, and where it's possible to have essentially every exercise becomes a little program. And the educators who are creating these tests are writing not just a test, but a little micro algorithm to represent the test. And then Ambar's system, Examiner, is able to take that micro algorithm and deploy it through the cloud to different students who are taking these tests, and then be able to aggregate the results together. And is able to do the analysis to find out that, yes, the students it really is working, that these students are not able to copy off each other or all these other kinds of things because of the kind of this is sort of the computational approach to assessment that involves all this kind of real-time randomization of what's being assessed. All right, our next award goes to Ambar Jain. So our next award goes to Omar Olmos in Monterrey, Mexico. And Omar has been using our technology, Mathematica, since version 2, since 1991, when he was studying plasma physics and doing research as part of his undergraduate studies in Monterrey. Then for his PhD, he used Wolfram language to develop a model for photon effects and nanostructures. at that time using Mathematica 8, which to us today seems so long ago. But he created a platform for doing numerical analysis of photon effects in nanostructures, which was then able to be used by future students working on similar projects. Since 2005, he's been the academic director of the science department at ITESM Toluca and has been using Wolfram language and Mathematica to create courses in mathematics, physics, and applied engineering. And his university has altogether 26 campuses with nearly 70,000 students, so a very large population he's been responsible for. One of the things that Omar has been doing recently that I thought was particularly interesting is the use of Wolfram language as a tool for doing the analysis of education analytics. And his particular concern has been optimizing the way that the large number of students that go through his institution interact with the institution and optimizing the outcomes for their educational achievement at the institution. And he's been able to collect all sorts of data. One very interesting kind of data that I simply had never heard of people collecting for educational analytics is biometrics data, things like heart rate data for students and so on. And he's been using Wolfram language as a way to analyze that data. I think that will be, I have no doubt that will lead to all sorts of interesting insights and successes for students in his university and beyond. I think that I'm very curious to know which classes will cause, whether I'm not sure if Omar is teaching classes himself, but if he is, it'll be interesting to know whether his students, if he looks at things like heart rate and stress, skin conductivity and so on at a biometric level, that's a much more precise version of rate my professors, to be able to actually see biometrically one's students' responses to a class. In any case, I'm happy to present our next Innovator Award to Omar Olmos. Thank you. Great.
Thank you very much, Stephen.
My pleasure. Our next award goes to Gustavo Restrepo, who has a startup company, Exergetica, in Bogota, Colombia, although he is currently in Moscow, Russia. So Gustavo studied chemical engineering in Colombia, and then for his PhD, moved to Moscow to study industrial thermal engineering, and was there introduced to Mathematica and Wolfram language for studying complex phenomena for heat and mass transfer and chemical reactions inside thermochemical reactors and so on. So Gustavo then worked as a process engineer in the energy and chemical industry, using Wolfram language to model heat loss and control loops that are involved in those industries. He's done a lot of different things with Wolfram language, from an early project here, unusual topic of the creation of a handbook for the reduction of smell emissions for the National Poultry Industry Federation in Colombia, together with heat and mass transfer calculations for methane steam conversion facilities, all sorts of different kinds of things, diesel tanks, all sorts of things. I think that the general theme is that Gustavo has been involved in the oil and gas industry in kind of I think primarily the part of it that goes from get the oil out of the ground to get it to separation and then to a refinery and so on. In recent times, he's been using also Wolfram System Modeler and has developed a library of hydrodynamic components to be used in the oil and gas industry as components to be used in the system modeling and ordinary differential equation solving that System Modeler makes possible. Also in the oil and gas industry is often one that has all sorts of interesting technology used in it. And Gustavo has been bringing some of that in developing, for example, a pump system, meta model designed using a trained neural network. So his business aims to implement, to use Wolfram language for oil and gas purposes in Latin America. And it's obvious that he's been doing a lot of interesting things in that area. So I'm happy to present our award to Gustavo Restrepo.
Thank you very much, Stephen. It's very important for me and for Exergetica to get that award. Thank you.
Our next award goes to Ariel Sepulveda. Ariel has been involved with the Wolfram language community for a long time. He got his bachelor's degree and master's degree at University of Puerto Rico, his PhD at Virginia Tech, applying on quality control and applying, I think, control theory to quality control. So he was first introduced to Wolfram language through Mathematica 2.2 in 1993, while he was a student at Virginia Tech. And he's used it ever since for all kinds of different things. Ariel has attended many conferences over the years. He was, for a while, a professor at the University of Puerto Rico, then a quality engineer at HP, and then then was involved in doing data analytics for retail data analysis for HP products. And for the last 10 years or so, I think, he's been a consultant working on bringing Wolfram language technology to data analytics in a variety of settings. And he's particularly known to us for the creation of a series of products that he's been delivering to a variety of clients over the years. He has a new product that he's been putting finishing touches to called D4CR that is very strongly based on, that is a Wolfram language product. And he's, I think, one of the sort of very strong users of our symbolic user interface technology. And he was telling me he's really happy that in addition to maintaining compatibility of our main functions in our language, we're also maintaining compatibility of the operation of the symbolic user interface, because that's what his products are based on. And his main objective is to take data that could come from databases and so on, and to find really elegant ways to present data in ways that are useful to management in companies in a variety of different industries. He's also started now doing some natural language processing for queries that can be asked from databases going through his dynamic technology. And he was just telling me that he's just started with his new product. He has his first couple of customers, one in the manufacturing sector, one in the primate research sector, where he was telling me that the data associated with primate research can be messy. And I was just wondering whether that's actually monkeys throwing food at each other, or whether that's more a reference to characteristics of the underlying data that might be in access databases or something at this time. But in any case, Ariel and his new product are on course to make that beautiful and to really deliver the capabilities of Wolfram language in settings like that. I think that Ariel, as many people this evening, sort of give evidence for my my sort of characterization of what we do as kind of bringing artifacts from the future to and applying them to sort of practical applications today. So our next Innovator Award goes to Ariel Sepulveda. Thanks.
Thank you. Thank you.
Our next Innovator Award this evening goes to Guy de Terramond, who is at the University of Costa Rica. He started life as a physicist. Got his PhD at University of Paris, Saclay, back in 1977. And actually Guy's advisor was a person called Mary K. Gaillard, who was a physicist who I knew back in the days when I was doing physics. And Guy told me he was actually her first student, although he didn't know that until she published an autobiography just a couple of years ago. And he said if he'd known that he was going to be her first student, he might not have picked her as his advisor, but I'm sure it worked out well anyway. Guy started off studying using essentially particle physics methods to think about nuclear physics and to think about questions like whether forces between neutrons and neutrons, nuclear forces between neutrons and neutrons are the same as nuclear forces between neutrons and protons and so on. Then went on and has done many other things in physics, publishing many papers on structure of strongly interacting particles and also grand unified theories and so on. I think there's kind of a theme that seems to run through Guy's work, that he's been involved in strong interactions, nuclear forces, and so on, in a variety of different periods in the development of particle physics. And in recent times, he's been involved in the idea of using the holographic principles and ADF-CFT, these correspondences between general relativity and conformal field theory, to find a new way to study QCD, to study the theory of quarks and gluons, the light front holographic QCD, and using that as a way to investigate strong interactions. But in the middle of all of Guy's physics work, he's also done a lot of work on the practical side of computing and science policy in Costa Rica. I believe he's known in Costa Rica as the father of the Costa Rican internet. He was responsible back in the 1990s for bringing the internet to universities in Costa Rica. Apparently in those days, it was a story. There weren't submarine cables and so on with fiber optics and so on. So it was a story of using satellites and such like to be able to deliver internet to the different universities around Costa Rica. I should say that he started using Wolfram language and Mathematica about 20 years ago for his physics and for many other kinds of things. One of the parts of Guy's background is that he was the director, the computer center at his university, but then he became the Minister of Science and Technology in 2000 for the country of Costa Rica. And at that time, continued his efforts to really bring the internet and computer technology to Costa Rica and bring computation to the education system, I believe not only at the university level, but also at the K through 12 level, bringing the internet and computation to schools in Costa Rica. So I'm happy to, and I gather Guy has also been involved in working with other countries in the region, connecting internet to other countries near Costa Rica and so on. I'm curious about some of the engineering challenges, particularly in areas where there's mountains and jungles and all kinds of things like that, about what's actually involved in getting the internet from here to there. It's an important and probably very challenging thing to do. Well, our next award goes to Guy de Terramond. Our next award goes to William Turkel of University of Western Ontario. I've been aware of William's work for a little while. He is a professor of history, and he is an example of another person who's bringing artifacts from the future to the present day and delivering computation to the humanities as a computational history and other kinds of, as an early member of the what I'm sure will be a rapidly growing field of computational humanities. He started using Wolfram language when he was working on his master's degree in linguistics at the University of British Columbia. where he'd also gotten a bachelor's degree in psychology. Then at that time, he was working on mathematical models of language acquisition and language change, but he's jumped around doing a lot of different kinds of things. He got his another master's degree in brain and cognitive science at MIT, and then a PhD also at MIT in history, anthropology, and STS, science, technology, and society, I think that stands for. I'm interested to see some Williams publications because they're so diverse. For example, one about how shocking experiments with strongly electric fish powered scientific discovery, or another one on rethinking inventories in the digital age, the case of the Old Bailey. Another one on using computer vision to explore sources in the history of stage magic. So I think even from a distance, I can tell that William is having fun being somebody who's delivering artifacts from the future to the present day, picking off some of the terrific things that are possible to do with computational methods in the humanities. I think he's been particularly involved in doing text analysis. He was saying that he was pleased to see that we now have PDF import working, because that's important when he wants to analyze 4,000 books to study. He was saying that he's interested in studying things like footnoting in different kinds of books, and was saying that academics, and this is a big surprise, are sloppier than you might imagine in making their footnotes. It's one of the things, in addition to William's books on things like electric fish, the book that I'm most familiar with is his book on digital research methods with Mathematica, came out in 2015. It's a open textbook that covers lots of kinds of things for the digital humanities and text analysis and beyond. And I kind of get the impression that William likes to use as many artifacts from the future as possible in the humanities, doing image processing, machine learning, and so on. He was mentioning to me a project taking electric circuit diagrams and doing image processing to analyze the history of electric circuit design through computational means. Well, so oops, I forgot my next slide here. There we go. There's a picture of William's book. Terrific. Well, our next award goes to William Turkel.
Thank you, Stephen.
Okay, last but not least for this evening, our final award goes to Mike Weimerskirch, from the University of Minnesota. And Mike tells me he kind of started off as a high school teacher, then went back to get his PhD in mathematics at University of Minnesota. And since that time, 2007, he's been involved in teaching, in the process of teaching math at University of Minnesota, and in particular in the placement of students, incoming students at the university, placing them into the correct pre-calculus and below kinds of mathematics classes. And so for that purpose, he's been involved in creating a big system. Actually, I should mention that Mike advises math majors at University of Minnesota, but his biggest project has been, I believe it's called the MOLS project, to do with the placement of incoming students at University of Minnesota. And for that, he's been working with our technical services group to build this large-scale system that is based on Wolfram language running in the cloud. This is serving about 1,400 students per year. It's able to provide detailed analysis that has been apparently very successful at matching up students with appropriate courses at the university. And I think there's a lot of interesting features in the system. It's the creation of questions has now gotten to the point where it's just the instructor can write a question in a notebook, and apparently it's kind of like have an idea while you're writing to work, if you're doing that outside of pandemic times. Kind of put it in your custom notebook and have that idea turn into something that can actually show up in the placement exam very quickly. So it's always great to see our technology used in these kind of large-scale education applications, and pleased to present this Innovator Award to Mike Weimerskirch.
Thank you very much, Stephen, for this honor.
Thank you. All right. Well, that is everyone here. As I say, I wanted to give you guys a little bit of insight about some of the things that some of these award winners have been doing. I personally find it really interesting learning about all of these different kinds of uses of our technology, and I find it quite inspiring, actually, to see the diversity of different uses that the things we've been spending all this effort developing can get put to. So thank you very much to all of our innovators here tonight. I think that's it for our Innovator Award program.